Okay, this is exercise 4.9. In exercise 4.9, they give us some time and the date and then population. So what we need to do is plot. They wanted you first for part A to plot population against time since 1790. So we're going to, I've listed all of them. I've already done that to save some time. This is the amount of years since 1790, and this is the population. So if we go to second stat plot, L1 versus L2. We do zoom stat, and notice it makes a nice curve. So notice it's somewhat exponential. So great, that's our clue that we might want to do an exponential plot for part B, because they want you to plot the logarithm of population versus time. So we go to my list and put in for L4, you can do an L3, but I just like to keep L4 to be the logarithm of L2 and L3 is the logarithm of L1. Logarithm of, L2. Okay, so then I go to second stat plot, and I'm going to plot L1 versus L4 now. Zoom stat. And there you go, you get a much nicer, straighter line. Notice it says how this, that the growth is still exponential but at a slower rate. Notice the slope. So that's the key for part B. So it's growing slower. Okay, part C, they want you to use the data from 1920 to 2000. So what's going to happen is I'm going to make time since 1920 my new L1. Basically, I'm just going to take this data here and delete until we get to 105.7. And then we'll go down and delete the rest of these. Okay, so then we still have to go over to L4 because even though we've changed, it doesn't automatically update. So I need to do the log of L2. And you've got that. All right, so second stat plot. Same thing, zoom stat, and notice, much nicer. So then we want to get an exponential model. So we go to stat calc, linreg. We're going to do L1, comma, L4. All right, so there you go. Our model in this case then is log of y equals 0.0054 x plus 2.03, where x equals time, y equals, it's time since 1920, y equals population. D asks you to find the r squared and construct the residual plot. R squared in this case is 99.5. So again, that means that 99.5% of the y of the population could be predicted by plugging in time since 1920 into this model. So I'm going to check my residual plot here. Go to second stat plot. Plot 1, I'm going to do L1 versus now I do the residual, which is under list. zoom stat. That's nice because notice there's no major pattern. So that's good. So finally, part E says to use the model to predict the population in the year 2010. Well, the year 2010 is going to be 90 years since 1920. So I'm going to plug in 90. So I get log of y equals 0.0054 times 90 plus 2.03. So 0.0054 times 90 plus 2.03, and you get the log of y equals 2.52. Actually, let's just keep it 2.516. So then to undo a log, remember we raise it above the base of 10. So 10 to that answer, 10 to the 2.516 gives us 328.1 million people. They then ask you, do you think the prediction will be too low or too high? I'll accept either or. The book says that they think it could be too low because of illegal immigration, but I myself think that that may also, I mean, obviously the actual population is always underrepresented. So I guess that wouldn't be bad.